Morning, everyone. Am I audible to you guys? Okay. So today we will just continue from the last class. Last class we were discussing about AVL Tree. Okay. Let me just share the screen first. Okay, last class we discussed about binary tree first. So I guess everyone is clear with binary search tree. So in the last class, we discussed about AVL tree. AVL tree is your height balancing tree. Okay, so in an AVL tree, it's also binary search tree. Then all the nodes have to like maintain a balance vector which should be in the range -1 to 1. So it can be either -1, 0, or 1. So whenever we add some node to the AVL tree, whenever we get some imbalancing, we perform four types of rotation. Okay, based on the imbalance level, we perform some rotation. So there are four types of rotation. One is left rotation, then we have right rotation, then left right rotation, and right left rotation. Then left rotation is also known as RR rotation. Wait, I'll just show you here. Screen is visible to everyone, right? Okay, okay. So first we will see the RR rotation. RR rotation means the new node is inserted to the right subtree of the critical node. Okay, that means from here you can see this is a tree, and whenever we will add some node to the right subtree and the right hand side of our right subtree, then we will perform a RR rotation. Okay, RR rotation means we have to perform a left rotation. So what happens here? This is your node A, this is B, and this is C, right? So the moment A, you can just see the right is an unbalanced tree. So here balance factor is 2. For AVL tree, balance factor should be it should be -2 actually, not 2, because 0 minus 2 it should be -2. Okay, so balance factor here is -2 because left hand side there is nothing, no subtrace, that means 0 minus 2. Right hand side there are two nodes, so 0 minus 2 is -2. So at this level it's -2 when there is an imbalance. So whenever we will see an imbalance, so we will perform a rotation. In this case, it's a this node is inserted in the right hand side of the right hand side again. Okay, it's like inserted right subtree of the right subtree, RR both. So what we will do, we will simply perform a left rotation. Okay, so what we are going to do, you just imagine it, this tree, you are just going to pull at this node and you are pulling it downwards. Okay, so the moment you pull it downwards, it will become, your B will become your root and A and C will become the children. Okay, so now your tree is balanced. Okay, this type of imbalance occurs whenever we insert a node into the right subtree of the right subtree. Okay, and it's a anti-clockwise rotation, right? Anti-clockwise, and it's a left rotation, hence you are just performing in the left. Okay, then next is your LL rotation. So in this case you can see your newly inserted node is at the left side of the left subtree. Okay, so for node C we have a tree, we have a left subtree B. Now I simply added A, so it's again in the left of left. So in this case we will perform a right rotation, that means clockwise rotation. So it's just opposite of the other one. You can just pull this node down here and now your B will become your root and A and C will become the children. So now it's the balanced one. Is this 2 point clear? It will be more clear whenever we will create an AVL tree. Okay. Let's wait till the lobby. Okay, stay clear. So next we have left right rotation. Okay, left right rotation means whenever we are going to insert something in the left uh, left subtree, then right subtree, right of left subtree. Okay, that means you just added a new node into the right subtree of the left subtree. So in this case, if you have inserted here, then you can see you just inserted it into the right subtree of the left. Okay, so in this case, we are going to perform two types of rotation. So LL rotation and RR rotation is your single rotation. Now this one a bit slightly complicated. LR rotation is the combination of right and left rotation. So it's just combination of RR and LL rotation. So first RR rotation is performed on the subtree and then LL rotation is performed on the full tree. So here you can see there's a imbalance here. So first what you are going to do, we just inserted it here, right? So first we will just perform the node below. Wherever we get an imbalance, we will go down. Okay. So in that node, first we will perform a RR rotation. That means it's a left rotation. That means you are going to simply pull the node down there. So now B become your root parent of A and A become the child. Now you see it's still imbalance, correct? So after this we will perform a LL rotation to the whole full tree. That means you will again push this node downwards. Okay, it's a clockwise rotation again or left rotation. So after pulling it, now B will become your root and A and C will become your children. Okay. So next is your right left rotation. That means you are going to insert a node to the left subtree of the right subtree. Okay, so here you are just adding a node to the left of right subtree. In this case, it's just again same, it's a combination of LL and RR rotation. So first we will perform the LL rotation. That means we will pull it down there. It's a LL rotation means your right rotation. Okay, single right. So after pulling it down there, we have to perform the RR rotation. Okay, that means again perform the left rotation. So in this case, you are just pulling it C down there. B becomes your root and C becomes your children. After that, you will just do the rotation into the full tree. So now you will pull down this A here and B will become the root and A and C become the children. Okay. Okay, let's do it will be clear. Suppose we want to construct an AVL tree. Okay. So nodes will be suppose 63. Eight, 99 and 81. Okay, so these are the nodes and we are going to construct AVL tree. So for any binary tree, we will always start from the left side. That means 63. First we will add 63. It will be our root node. Okay. So next we have 9. So remember binary tree, the 9 will be added where? It's a binary search tree. AVL tree is also a binary search tree. So 9 will go where? Left or right? Left or right? Left, correct. So 9 will be added here. Now you see the balance factor. Initially it was 0. At this point is 1 minus 0. Balance factor is 1 here. For this node, it's 0. Okay. Next node we have 27. Okay. 27 where we will add it? We will add it where? Let's add another number here. Okay, first we have 99. Step 1. We have 19. 19 we will add where? Right. So 19 we will add here because it's greater than 9. So for binary search, all the nodes, all the numbers, those are less than the root node will be in the right hand side. All the nodes greater than the root node will be, sorry, all the nodes less than root node will be in the left side and the greater than nodes will be in the right side. So now you check the balance again. What will be the balance factor for 63 now? For this node, what will be the balance factor? It will be 2. Why? Balance factor means height of left minus height of right. Correct? So height of left means 1, 2, 2 minus 0 is 2. So at this point, height of balance factor for 63 is 2. For 9, it's what? 0 minus 1. It's minus 1. And it's 0. Okay. Now you see we have a unbalanced. The tree is not balanced. Correct? The factor is here. So what rotation we are going to do here? We have added a node in the right subtree of left subtree. That means we will perform what rotation? Left right. Yes, correct. So we will just perform LR rotation. So LR rotation means what? First, we will perform a left rotation. That means 63. First, we are going to just pull this one here. That means your 19 will come here. Okay. Then your 9 will go down here. Okay. So at this level, still your balance factor is 2, it's 1 and it's 0. First, we will perform the left rotation onto the node just below the imbalance one. Then after this, we will perform a second rotation, that will be your right rotation into the full tree. That means we are going to pull it down here. So ultimately 19 will become your root, 9 will become left child, and 63 will become your right node. Now you see the balance factor. It's 1 minus 1, 0. It's 0 and it's 0. Correct? So this is your lefter rotation. We got this. Okay. Now what's our next node? It's 27. So 27, where we will add now? 9, right? 27. 27 is larger than 19. Left of 63. Correct. So we will add 27 here. So now you see the balance factor here again for the 19. 1 minus 2. So 1. For this one 0. For this one 1. For this one 0. Okay. So this one is balanced. No need to do anything. We move forward. Now we have 18. So let's do it again. So 18 we will add where? 18 is less than 19, correct? So it will be added where? Again it's greater than 9. So we will add here. So again see the balance factor. It's 2 minus 2 0. For 63 it's 1 0. It's minus 1 and it's 0. So again it's balanced. No need to do anything. Correct? Next our node is 108. So 108 will go where? 108. Where will I add it? 108. Right of 63. Correct. I'll add 108 here. So again see the balance factor. What's the balance factor here? 2 minus 2 0. For 9 minus 1 0. For 63 is 0. 0 and 0. So no need to do anything. Correct. So our next node is 99. 99 will go where? left of, correct. So it will come here. Now see the balance factor again for this one. 2 minus 3 is 1. For this one again minus 1, this one 0, this one is 0. For 63, 1 minus 2 is minus 1, 0, and this one 1. So it's again balanced, so we don't need to do anything. Okay. So next our node is 81, last node. So now you add 12, put 81 where? Left of 99. Good. 81. Okay. Now you check the balance again for 19. 2 minus 1, 2, 3, 4 is minus 2. For this one remains same. For 63, 1 minus 1, 2, 3 minus 2 is 0. For 108, it's again 2 minus 0, it's 2. For here 1 and 0. So what rotation? Now it's imbalance, correct? So what we have to do now? So what rotation we need to do? The newly added node is at the where? Left of left. Yes. So we will perform LL rotation. Correct. So LL rotation means what? We will simply pull it down here. Okay. So the node will become 19, 19, 3, 27. Okay. So at this point we will perform a left rotation means what? We will just pull it down here. That means 99 will become a node, 108 will become left, and this one will become here. Now we check it again. 2 minus 1, 2, 3. So 1. For this one, same 1 and 0. For this node, 1 minus 2 minus 1, 0. For this node 0, 0, 0. So all nodes are balanced. So this is our AVL tree. Okay, this is our required one. So is it clear? No, it's not left right rotation. It is simple LL rotation. Why? Because we have added the node into the left subtree of this left node. Imbalance, first imbalance is at this level 108. So 81 is added to the left of left. So it's a LL rotation. Okay. So is this clear? How we create AVL tree and how we need to balance out all the factors. We have to maintain the balance factor. Whenever we see balance factor is not in the range of minus 1 to 1 including 0 means minus 1, 0 or 1, then we will perform rotation based on the location of newly added node. Is this clear to everyone? Ma'am, how do we get that 0 minus 1 didn't get out? Okay. This is your balance factor. Okay. For AVL tree, I have already mentioned balance factor, you will find out height of left subtree minus height of right subtree. Okay, so in this case, what is the height for the left subtree? Left subtree means this is your left subtree, correct, for this root node, and this portion will be, this is your left subtree and this is your right subtree, correct. So again, for this node, this is your left and this is your right. So for every tree, we have left subtree and right subtree, correct. Again, it's a binary search tree, so we have to make sure all the nodes in the left will be less than your root and all the nodes in the right side will be greater than your root. Okay, greater than equal to, actually it can be even equal. So for this node, for 19 node, what is the left height of lefts? It is 2. How do you calculate the height? Is the longest part from the root node to the leaf node, correct. So for this one is 1 2 and 2 minus 1 2 3. 2 minus 3 is minus 1, so balance factor is minus 1 here. For this node, left subtree is empty. That means it's 0 minus, there is 1, right subtree 0 minus 1, that is minus 1. Again, for this node, there is no children. For leaf node, it will be always 0. Okay, for 63, one node at the left side, that is 1 minus, and for we have 2, 1 minus 2 is minus 1. Correct? So it's a leaf node, balance factor will be 0. For 99, we have 1 left and 1 right. So 1 minus 1 is 0. So that's how we calculate the balance factor. Height of left subtree minus right subtree. Is it clear now? Okay, good. Left subtree. So it will be applicable to all the nodes. Okay. So is this clear? How we can create an AVL tree and how we perform the rotation? Everyone, I'll give homework for this. You guys have to do one. Okay, in some books, or if you see even online, you will see sometimes they mix up the things. Means they say this one is a RR rotation, and they just mix up the LL rotation and RR rotation. Okay, don't get confused. Sometimes they just put it wrongly. They say single left is a LL rotation and single right is your RR rotation, but that's not the case. Single R rotation is not RR rotation. RR rotation means whenever you insert an item into the right subtree of the right subtree, that is called your RR, right of right. And LL means left of left. Single left is not LL and single right is not RR. Don't get confused. In some of the books or sites, you will get like that way. Okay, I understood, but the name is confusing. LL means left of left. Left of left, you just think. So it is LL. Okay, but it is right rotation. So this is your left of left, but your rotation is your clockwise. That means you are doing the rotation in the right side. Correct. But it is clockwise. For LL, rotation is clockwise. Yes, so it's a right rotation. So it is equivalent to single right, and right of right is equal to your RR rotation. That means it will be your left. Right of right means it will be something like this. In this case, you will perform an anti-clockwise and it is a left rotation. Okay, we are doing this in the left side. So in some book, what they do, they just say single left is your LL and single right is RR. That's not the case actually. LL stands for left of left and RR stands for right of right. And you just need to check it. In this case, you can see the imbalances here. So you are going to pull it this side, right? And if imbalance is at this side, you will just pulling it at this side, correct? Is this clear? The name is just like your LR means what? Left of right means your LR, correct? And right of left means your RL. Okay, this is how you insert your thing. So these two are double rotations and these two are single rotation. So is this clear? AVL tree, everyone? Kind of. Okay, and maybe I'll just give you an homework. Whenever you will do it yourself, it will be more clear to you guys. Okay, just see where the imbalance is causing. Okay, so this note you have just added here. So you are not going to consider the whole thing. मुझे भी confusion हो रहा है. नाम में confuse मत करना. You just see the name. RL जैसे left of right, RL जैसे right of left, LL मतलब left of left, RR means right of right. Is the insertion. It's a bit confusing. Even lots of sites or books also do that confusion. So they just say single left rotation equal to LL. But this is not the correct one. Actually, LL rotation is your right rotation because you are going to rotate it into the left one. You are going to rotate into a clockwise direction. That means right side of you. Others, is this clear? So if this one is clear, I'll give you homework. Like, you guys try to write it. You guys do it yourself. Okay. This one might be a bit complicated to you guys, but still try, because sometimes when we do rotation, your children might get changed. Okay? Okay, I can show you one of that example. This is your homework. Write it down first. Everyone wrote it down? Let me know. Okay, done. Okay, I'll just quickly show another one so that you get it. So suppose I'm just going to insert number 1 to 8. Okay. So first I'm adding 1, that is just 1 to 8 numbers. 1 will be the root. Okay. Next I have to insert 2. Right. So 2 is better. I'll put it here, number 2. So now your balance factor will be here -1 and here it will be 0. Right. So next I want to insert 3. So the moment I insert 3, I have to insert it this side, right? So now your whole game get changed. So what will be the balance factor for this one? It's -2, 0 minus 2, and for this one it's -1 and 0. Now what we have to do? I have just inserted it to the right of right. That means I need to perform a left rotation or RR rotation. So I'll just pull it down. So 2 will become root. Here it will be 1 and will become 3. Correct? So now balance factor is 0, 0, 0 for everyone. Okay. So now I want to add 4. 4 I'll add here. Correct? So now you see your balance factor is again 1. It's 1, 1, 0, and 0. Okay. So this one is already balanced, no need to do anything. So again I add 5, number 5. So number 5 is again I have to put it right side of here, right? So balance factor for this one, 1 minus 1, 2, 3. It's -2, it's 1 minus 2, and for this one -1, 0 and 0. Okay. So now what I have to do, again I added right side of the right tree of this tree, so it will be a RR rotation. That means it's a left rotation, single left. That means I'm going to simply pull this down here. So 2, 1, 2 will be here, 2 will be here, and 5 will be here. Now you see it's 1 minus 2 minus 1, 0, 0, 0, 0. So it's fine, no problem. Next I want to add 6. 2, 2, 3, 5, and 6. I'll put it here again. So again see the balance factor 1 minus 3 minus 2, it will be minus 1 minus 1. Okay. So you can see there is a mismatch. Correct? So now what I have to do, your imbalance is at this point, right? The rest is fine. This is just 0. So where I'm going to pull it, I have to pull this down now, correct? So since our imbalance is here, I'll simply put this down. That means in this case, what will happen? It is again the same LRR rotation, but when we move it clockwise, it will become, means 4 will become your here, 5 will remain same, 2 will come down, 1 will come down. Now we have a 3 here, correct? 3 was your fourth left child. Okay, in this case, this 3 will become your left side of, sorry, right side of root 2. Okay, in this case, it's going to be a difference. The left child of 4 will become right child of 3. Okay, so in single rotations, normally we perform at the same node where we get the imbalance. But in case of double rotation, we first do it just one node below, then we do it in the first node. So see here it got changed. Now you see the balance factor. It's same for 0, it will be 0, it will be minus 1. Okay, it will end in 5 minutes. Anyway, so after that I want to add suppose 7 to this point 3. At this point the 3 becomes just right child of 2. 5, 6, I'm going to put it 7 here. So now you see again it's 2 minus 1. It's 0 minus 2, it's 2 minus 1. That's this. Okay. So now what I have to do? The imbalance is here. In this case, it's just simple. I just need to put it down here. So it will be just simply 4, 2. Here I will again perform right. That means 6 will become node, 5 and 7. Okay. Next I need to insert 8. If I add it, I'll just put it here. Correct? So it's already balanced. 2 minus 3 is minus 1 here, minus 1. Okay, so this is your AVL Tree. So in this case, you just saw the difference is at this point. Whenever imbalance is at here, this point, right? So I perform a RR rotation. That means your left rotation. I just pull it anti-clockwise, right? So at this moment, this will become the child of 2. Okay, is this clear? This is another condition. So you guys just try the homework for this one. I hope this one is clear to you guys. Okay, this is your homework. So I just gave you this example because for this case, you might get something like this where you need to uh, change the children of one node to the other. Okay, so I'm going to stop sharing. Take your attendance. Today's class clear to everyone? AVL Tree. You just do the homework, it will be clear. And yeah, after doing it, everyone needs to send screenshot or anything. Okay, so I'm ending the meeting now. Thank you.